In our previous video, we introduced Green's theorem in two different forms. Here's the circulation curl version, and here's the flux divergence version. So let's practice working with Green's theorem in both versions by verifying them, verifying both forms of Green's theorem for this vector field, x minus y times I hat plus xj hat, and the region inside the unit circle is centered at the origin. So what that means by verify Green's theorem is that we're going to compute the left side, this as a line integral, the right side, this as a double integral, make sure that we obtain the same answer. So verify both forms of Green's theorem. So we'll also do that for this. Calculate this and calculate this. So we have 1, 2, 3, 4 integrals to compute. Okay, so here, let's see what's going on. We can see that m shouldn't have a hat on it. M is equal to x minus y, n is equal to x. Region inside the unit circle centered at the origin. So this is what we're thinking about. The inside region, this is our R, and the boundary, this is our C. We need a parameterization for C here. Of course, easiest parameterization for the unit circle is just to say R of t is equal to cosine t times I hat plus sine t times j hat, where t runs from 0 to 2 pi. Okay, so to compute, let's see here, let's get the circulation curl 1 first here. So to compute the left side here, this is a vector line integral. What we have to do then is we need to rewrite m and n, substituting in r of t here. So x is cosine t, y is sine t. So m will be cosine t minus sine t, and n will be x is cosine t. Meanwhile, let's see here, r prime of t, the derivative of our parameterization is going to be, I'll write it using these brackets here, negative sine t comma cosine t. And so the integral that we have to compute for this right here is going to be the integral from 0 to 2 pi of cosine t minus sine t comma cosine t dot product with negative sine t cosine t. All of that dt. Okay, so let's see here. This is equal to integral from 0 to 2 pi. Cosine t times negative sine t is negative sine t cosine t. Then negative sine t times negative sine t is plus sine squared t. Cosine t times cosine t is so positive cosine squared t. And take a look here, we have sine squared t plus cosine squared t, that's equal to 1. Okay, so at this point then, I'm just going to rewrite this as an integral from 0 to 2 pi of 1 dt minus the integral from 0 to 2 pi of sine t cosine t dt. Of course, this first integral is equal to 2 pi. For the second integral, we can evaluate this by substitution. Substituting in u is equal to sine t, du is equal to cosine t dt. So there is going to be du. So it's 2 pi minus the integral of u du. When t is 0, u is sine of 0 is 0. And when t is 2 pi, u is sine of 2 pi, that's also 0. And I mean, the integral of anything from 0 to 0 is just going to be 0. So, okay, this shows that the left side of our circulation curl version of Green's theorem, this over here, this is equal to 2 pi. So by Green's theorem, this expression over here should also equal 2 pi. The double integral of partial derivative of n with respect to x minus partial derivative of m with respect to y over r. What is r? R is the unit circle here. That also needs to equal 2 pi. So let's go ahead and see that. Let's go ahead and compute that. So partial derivative of n with respect to x, partial derivative of m with respect to y. So that's going to be the derivative of n with respect to x is 1 minus the partial derivative of m with respect to y. The partial derivative with respect to y is negative 1. So we are finding the double integral of 1 minus negative 1. We're finding the double integral of 2 over this circle. And this circle here is just a circle of radius 1, centered at the origin. The area, the integral of a constant, the double integral over a constant over a region is just that constant times the area of the region. And a circle of radius 1 has area pi times 1 squared is pi. So 2 times pi, and that checks. So what did we do? We took this f here, and we took this circle with the region inside of it, and we computed both this side and this side of Green's theorem, and we got 2 pi. So we verified Green's theorem in this case. Okay, we have one more task to do here, which is, we said, verify both forms of Green's theorem. So let's also do this for the flux divergence version of Green's theorem. So the double integral of the flux over the the outward flux across C equals the double integral of the divergence over the region in question here. So let's go ahead and I'm going to start with, just to mix things up, start with the right side here. So if m is x minus y, let's recopy that. M is x minus y, n is x. The partial derivative of m with respect to x is going to be 1. The partial derivative of n with respect to y is going to be 0. So we are integrating 1 plus 0. We're integrating 1 over the region. And so this is going to be 1 times the area of the region. This is just going to be 1 times pi, so just pi. So note, let me point out something here. We are getting a different answer pi than this here. So Green's theorem says that this expression is equal to this expression, It also says that this expression is equal to this expression. It does not say that all of these expressions equal. So these do not equal these. Okay, so one more thing that we have to do now is to do this calculation right here. And so what's going on is that, so we have m is x minus y, n is x. Don't forget we have our parameterization. We're still having this parameterization right here. So let's recopy. M is cosine t minus sine t. N is cosine t. So then for integral of m dy minus n dx, well, let's see here. In this parameterization, dy is going to be cosine t dt, because y is sine t, so dy is cosine t dt. Dx is going to be, x is cosine t, so dx is going to be negative sine t dt. And so this is going to be the integral from 0 to 2 pi of m cosine t minus sine t times dy here, cosine t dt, minus n cosine t times dx, negative sine t dt. Okay, so expanding everything out here, we end up with, so we can move the dt to the end. And so we'll have cosine t times cosine t is cosine squared t, minus sine t cosine t, and then minus times minus is plus sine t cosine t. And so those terms cancel. So we're just left with an integral from 0 to 2 pi of cosine squared t dt. And this is equal to pi. You can use double angle, half angle formulas to replace cosine squared t with simpler things. A hand-wavy explanation is that on average, cosine squared t has value 1/2, so integrating that from 0 to pi gives us pi. And once again, pi is equal to pi. So yes, we have successfully verified now the flux divergence form of Green's theorem. We got pi here, we got pi here. So hooray, we have just verified Green's theorem.